We are a team of 4 people now presenting. So it's me, Bjørn, Karim, Abjot, and Morten. And we all work at the HISP Center at the University of Oslo and are developers of these tools. We'll also mention that this has been funded with a grant from Wellcome Trust and is part of the climate and health project that is going on at the HISP network and HISP Center. So what we plan to cover, I will give you a short introduction about the climate tools. And then we will have a walkthrough by Karim and also present the underlying library that is called DHIS2 EO. And then Abjot will present a Python client, a generic Python client that is part of the climate tools, but also make it super easy to communicate with DHIS2 from Python. And then Morten will show you how to automate these processes so it can be run at fixed intervals, so you can keep your data always up to date, which is an important requirement for these early warning systems. And then hopefully we have time to show you how you can contribute back to these climate tools and some feedback and questions at the end. I will also want to mention that this is both like a standalone webinar as a general introduction to the climate tools, but it's also part of this webinar series on spatiotemporal modeling that I know a lot of you are following. And I would especially recommend to look at this session 4, which goes as a nice add-on to this webinar. So we won't discuss so much about the linkages between the climate and health field. Then you should watch this session 4. This is more about when you have decided which climate data you want to use, how you can download it, aggregate it to your district's health district, and then also pushing it into DHIS2 and the chat platform. So what is the climate tools? It's like your entry point will be to go to this web page where you will find all the information about it. But briefly, it is open source libraries and workflows where you can both access, process, and upload climate data, but not only climate data. It can take basically any type of data into the DHIS2 and this modeling platform that we have, and that is presented in this webinar series. The tools are based on the Python programming language, so we are using the same programming ecosystem as the chat platform. And this is especially well suited for the processes we want to do here. An alternative name to the climate tools could be the GIS tools, because it's very connected to geospatial and GIS processing and handling. So why have we created these tools? We have now worked on this field for 2 years. I will mention the climate app that many of you know, but based on requirements that we have seen from these 2 years, we have created these new climate tools. So one of the requirements is that we need to be able to work on all sorts of data. So this can be global and local. It can be everything is connected. So climate data is often not enough to make good predictions. So we need environmental data, socioeconomic data, a lot. And to try to cover all of this into an app, a generic app, is impossible. So we rather need to shift the focus to make a flexible framework where everything can be included. We also need to adapt to local needs. There is very hard or it is impossible to build a generic solution that works in all local contexts. We see there is a lot of innovation going on locally and in the countries, and this is a platform where we all can share with each other. Then it's so important to have that for us, as with DHIS2, that everything is open source. So we need to avoid we want to avoid any vendor lock-ins with these tools. So everything should be open and transparent. There is also a complex field, and there is a lot going on. And rather than trying to making things from scratch, we try to build on existing tools and services as much as possible, and then just add small pieces on top of it. And it's also important to adapt. So there is so much innovation, new services coming basically every month. So we try to make this a flexible platform where we can easily incorporate new services as they become available. And also, as mentioned, it's important to automate this flow. So to be able to create an early warning system where we want to make advanced warnings, it's important that these data flows goes automatically. So we always have the latest climate weather forecast available. And then it's also, we are so dependent on trust. So with these notebooks we will share later on, where we have the full transparency of all the methods, techniques linked to scientific papers and so on, is very important. So we envisioning two main uses of the climate tools. So the role we will focus on today is more the data engineer that wants to integrate climate and environmental data from different sources and then aggregate these to the health districts, for example, and import this data into DHIS2 or the CHAP platform. Another use case is more the data scientist. So in DHIS2, we're not supporting being able to work with the raw climate data, which is often at a much higher resolution than when it's aggregated to a district. And this can reveal different insights, and it's a lot of processing things you can do with this. And this platform allows you to operate on the raw original data. So this climate tools is part of a bigger suite of tools. So many of you already know the climate app, which is a very easy way to import data into the core platform, into the database, but this one has a limitation that is currently dependent on Google Earth Engine. And if you don't, Google Earth Engine is a great platform, and we're happy to have this collaboration with them. But if you would like to have an alternative and get the data from another source, you need to use the climate tools. I will also mention that the climate app won't be only dependent on Google Earth Engine. We will soon have this Annex initiative that you can connect to servers in the country with local climate data that is controlled by the Met offices in the countries. And we will release that now soon in February. But when you have the data in DHIS2, you can then push it to this CHAP platform and through the modeling app, and then make predictions into the future, which is covered in other parts of this series. But the climate tool sits here at the bottom, so it does the same as the climate app. So basically, the main purpose is to take climate data and harmonize that to the health district, so it has the same time and space resolution as the health data, to be able to do this combined analysis. And then in addition, we have also now we'll present later today, the ability to transfer data directly from climate tools to the CHAP platform. So you don't need to go through DHIS2 if that makes it more convenient. We'll just briefly mention the climate app. So if you find this climate tools a little complex, it requires some basic programming skills, then you should try out the climate app. So it's just an app you install in DHIS2. You automatically get your org units hierarchy, your districts for your DHIS2 instance, and on the fly you can look at the climate variables and also import this data to DHIS2. So compared to the climate app, this is a much more flexible platform. So it's not only the data sets we provide in the climate app, you can basically import whatever you like. So it's highly customizable, but it also comes with an extra cost that you need some basic programming skills. and it needs to be hosted. You need to run it somewhere. But we think having these both options will give you a lot of flexibility. Also, as I mentioned, there is a lot of tools out there already, and we try to build on top of this, both existing standards like this NetCDF format that is very widely used for climate data. So you can bring in local NetCDF files, but also new initiatives. And there is often this challenge that these datasets are enormous, huge. They have a high time resolution, very high spatial resolution. So just being able to work on this locally in an effective manner is an important goal with this project. We'll also mention that we couldn't rely on existing tools alone. So we have also two libraries that we provide as part of this climate tool. So one is this DHIS2 EO package that Karim will present in a minute. And then we have this Python client that handles the interaction with DHIS2. So all in all, you have a lot of power within this ecosystem. Then I will hand over to Karim.
All right, thank you. I will share. Okay. All right. Well, thanks everyone for coming. So yeah, there's a few different challenges when working with climate data for with DHIS2 and health. So one is how to get climate data. So for this, to make this process easier, we've made this DHIS2 EO library. So it's a Python library. So the audience is for DHIS2 users that want to work with Earth observations. So that's the EO at the end of the name. So anything like climate data, environmental data, and so on. And one of the main purposes is to be able to easily download climate data for your country. So you can define which area you're interested in and connect to a data source, and then you easily download those data to your local computer. So currently, we have a few data sources supported. So ERA5 land from so they have from the European ECMWF, 9-kilometer resolution for the whole world, and it's hourly data, and it goes back many decades. They have 50 total variables, like climate variables. So you have like a whole suite of things you can explore. So temperature, precipitation, humidity, wind, soil, runoff, even vegetation index, and so on. So that's a very rich source, and it's very high resolution. There's also CHIRPS. So this is a 5-kilometer resolution data. They're considered to be very good at precipitation. It's at a daily level. And then we also integrate with WorldPop. So they have this very high resolution at 100-meter population count data for the whole world, and it's for for 2015, and it also projects into the future to 2030. So those are the data sources we currently support that you can easily grab with DHIS2 EO library for your country or for an area that you're interested in. The library also has some utility functions to convert these climate data after you've aggregated and into a DHIS2 supported format. So it's like a helper library to get started, but these are global sources, but so it helps you to get global data, but you don't need to use this if you have local data. You can just as well use that, like some file on your computer or the file from your from a local office or something like this. So yeah, so that's for getting, this is just a helper utility to help you get your hands on climate data. So another common challenge with climate and health is how to harmonize the climate data with your health data. So on the one hand, you have the time dimension. So for instance, this ERA5 land and a lot of other climate data is reported at the hourly level. So for every hour, you can see like this graph on the left, how the temperature varies throughout the days. In DHIS2, the smallest reporting unit is at the daily level. So we have to convert from this hourly to the daily. So we have, for instance, in the Climate Tools toolkit and on the website, we have this example that shows you how to go from hourly data to daily data. And that includes things like handling. If your country has a different time zone, you have to convert correct to get the correct days. So that was in the time dimension, how to harmonize there. And then also on the spatial dimension, so climate data is gridded data typically. So as you see on the left here, these are grid cells or pixels at 9 kilometers. But we want to get into the health districts on the right side. So here you're seeing DHIS2 organization units. So how to get those grids and pixels into the administrative unit or health district boundaries. So we use this EarthKit. They have a very convenient functionality to do this. So I will just show you a little bit more in detail how this is done. The spatial aggregation, and we have some. So this is the Climate Tools website. So we have a lot of different guides here, so we're only showing a few of them today. And these are all, so all the ones that we'll be showing are Jupyter notebooks. So I'll just actually show when you go to the Climate Tools website and you click Get Started, you can follow this installation guide. This will download the whole all the notebooks and all the guides to your computer, and you set up your environment so you have all the tools you need, and then you can actually explore all the guides on your computer through this interactive notebooks. So I'll show you this. This is just on the website, but I could also open this on my computer. Okay, so so this is about how to aggregate climate data to health districts. So we start by just importing what we need for libraries. In this example, we're using ERA5 land data at the monthly level. So every month between 1990 and 2025. So this is just a file we have already downloaded to the computer. And but it can just as well be anything. Like it doesn't have to come from ERA5. It can be a local data source that you have. So you can switch that out, and the process will work the same. And then we use this XArray Python package, which is very useful to open the dataset. We look at the contents of the file. We can see it has 428 on the values in the time dimensions. So that's how many months there are in that year in those 35 years. And then we load the health districts. We've downloaded this as a file, a GeoJSON file from DHIS2. So these are our health district boundaries. So if we inspect the contents, we get this table. So each of the health districts in Sierra Leone, and this is their ID. And if you scroll over here, we also have their geometry, like their actual boundaries. So Yeah, so then to aggregate the climate data to the health districts, we start by looking at temperature. So we just select a month. We look at July 2025, and we look at temperature, and then this X-array has a very convenient way to just plot the data to visualize. So we can see this is the temperature gridded data for the area around Sierra Leone. And then to aggregate, it's actually quite simple. It's a one-line function. This is from the EarthKit library. So we just give it the temperature gridded data. We also give it the health districts or organization units. And we tell it to aggregate, take the average temperature for each health district. So after we aggregate, we can then convert this to a pandas data frame. So if you're a data scientist, you will likely be familiar with this. We can visualize it. So we see the DHIS2 ID for each of the organization units. And then we see for each of the months, we have a value for temperature, like an aggregated value. So this is the results of our aggregation. We can also then merge this aggregated data frame to the health district boundaries that we loaded in the beginning. So with these simple 3 lines of code, we can also then plot what the aggregated data looks like. So here we see that the temperature for the health districts are higher along the coast. And we see that matches with the original gridded climate data. So that's that's kind of the simple steps to aggregate. And I'll just briefly show how this is done for precipitation too. It's the same process. This is what the precipitation looked like in July 2025. And then we again aggregate the precipitation to the health districts and convert it to a pandas data frame. And we can see that we have the aggregated data values here. And again, we can merge it back to our health district boundaries and visualize what that looks like. And we see that again, the precipitation here matches roughly what we see in the original climate data. So that was just a little bit of a walkthrough of the process for harmonizing gridded climate data to DHIS2 organization units. So then I'll just show, so those are some of the challenges you have to go through. And so we also have like notebooks that show complete workflows. So here we are looking at if you want to import the climate data into DHIS2, we're going to go through that process. So the process starts on the left side here. So your DHIS2 instance will has the health districts defined. So we use this DHIS2 Python client that Bjørn mentioned, and that Abjot will cover soon. To connect to DHIS2 and then grab the health districts as they are defined and their geometry and boundaries. And then then we have the health districts. Next, we want to get the climate data. So if you want to use global climate data, you can use this DHIS2EO library to download this to your local computer. Or if you have local data, you can just load this directly, as I showed in the previous example. And then we take the climate data and the health district boundaries, and we aggregate it like I showed in the previous slide. And then we have something that looks more similar to what DHIS2 expects, but we have to convert the pandas data frame to the JSON format that DHIS2 expects. So we do that with the DHIS2 EO library. And then again, we use the Python client to push the aggregated data values to DHIS2. So that takes you through the whole workflow. And I'll just show briefly what that looks like. So this is the notebook that goes through this process. And you can, so this actually, if you download the Climate Tools to your computer, you can actually run this and make it work on your computer. So there's some prerequisites. So you have to get API access to the climate data store. That's where we get this, for this example, that's where we get the ERA5 land data from. And then you also have to have a DHIS2 instance to connect to, and you need to have the data element. So that we will import the climate data into. So in this example, we're going to be importing precipitation. So you need to have, it's basically like a variable, like that you need to have defined in your DHIS2. So if you have those things, then yeah, this is just importing what we need. So at the top of this one, we just define a series of input parameters that you can easily change. So for this, if you were to run this on your computer, the most important things you have to change is this data element ID. So because you'll likely be working with a different DHIS2 instance, you need to make sure you create the data element and put the ID here so that the script knows where to import the data into. The other thing is this org unit level. So in DHIS2, the health districts are defined at different levels. So the level 1 is the national level. In Sierra Leone, level 2 is the province, and then level 3 is further down districts. So in this case, we're importing 2 provinces. Yeah, and you can also find the time zone that you're in of your country. So Sierra Leone happens to be UTC 0. Okay, so, and you can also play around with these, import different variables from ERA5. And define which, like that it starts, you want to import data starting in January 2025. And here it's actually automatically trying to import into to the latest day, like to today's date. So every time you run this script, then you'll get the latest data. So the first step is connecting to DHIS2. That's using this Python client. So we can see the DHIS2 version. And then we get the organization unit or the health districts from the DHIS2 instance. And then we can see the contents, kind of like we saw in the previous example. We also check when we can also query DHIS2 to ask when this data was last imported. So the Python client has a utility for doing that. And then we just make sure we don't have to re-import the same data or re-download data. So then to the actual downloading of data, this is using the DHIS2 EO library. So it's just this one function, basically, the ERA5 land. We want hourly data and then download. And we say, this is a standard interface that we have for most of the download functions or integrations. So you say which day you want to, like the start date and the end date for data you want to download, the bounding box or area that you want of the organization units, or if you want to look at some other area. And then where on your computer you want to download the data to. So it's and which variable to import or to download. These functions also cache the results. So if you download it once, the next time you run the same function, it will just reuse the same files that you have already downloaded. And what it returns is a list of the files that you have that are downloaded for climate data. So then after we have all the files we need, we can use this Xarray library again. They have a very nice functionality to open multiple files at the same time and treat it as a single data set. So we do that here, and we can inspect the content. So we see it has 8,760 values on the time dimension. So that's how many hours there are in a year, because we downloaded a year of data. For precipitation, it's a little bit of a special case because it's recorded as a cumulative variable. So for each month, it just keeps adding the value to the previous value. So at the end of the month, you have the total precipitation for the whole month. But what we want is to break it down so we know how much precipitation happened on each day. So in this step we just kind of we handle that, we convert that to daily values or to hourly precipitation, and then we go on to the temporal aggregation, what we talked about earlier. So we're using EarthKit here to aggregate hourly data to daily data. And we use this what you set higher up earlier for the time zone. So that the hours are correctly aggregated to the days, how they are defined in your country. After that, we do the spatial aggregation. That's what we talked about more previously. So you see, after we do this, we have, so ID here is health district ID. So we have 13 districts and 365 days. So that's the correct harmonization that we need. And then we convert the Xarray to pandas data frame, and we can see the contents more clearly. We also then, this precipitation is reported in meters, and we want to have that in millimeters. So we handle that, convert to the correct units we want. And then we're getting towards the end. We're using the DHIS2 EO library to convert this pandas data frame to DHIS2 JSON format. So this is what that looks like. So this is the payload we're going to be sending to DHIS2, and then we use the Python client to send those values, the aggregated data, to DHIS2. So that takes you through the whole process, and then you get a status of what actually happened. So it imported 4,000 values. So I think, that's it for me. So how do I have? Yeah, so that's one example of how to import data into DHIS2, and then now Abhyut will see.
Yeah, thanks, Karim.
I don't know how to stop sharing. Oh, here we go. No, find it.
Thanks, Karim. So thanks all for joining. Just share my screen here. I hope you see my screen. Yes. So what we just saw from Karim is like one of these data kind of pulled from their source. Technically, it could be both global data or local data, and then kind of go through the required harmonization process. For example, earlier Karim just showed us how we moved from daily temperature data from hourly to daily, and then finally pushed into DHIS2. So that's fine. But then if you also saw the slide from Bjorn, there was one arrow at the bottom where we can feed direct from Climate Tools direct into the chart. So what we have here in the notebook is we have the temperature data, for example, precipitation, population, and then we also can have the same workflow for dengue data. So the actual disease that we wanted to predict based on these input values or covariates, if you like. And then if you are going to feed into CHOP, we need to kind of pull all this and then harmonize it and then kind of pass it through the Climate Tools API. Then make sure that is kind of consumable by the CHOP, and then there you go, we are ready. CHOP had all the data that it needs to go through all the training and then the prediction. So what is important here is to make sure all the data that we fit, because we have the temperature here, the precipitation, population, dengue, the actual case, all this need to be kind of on the same spatial and temporal dimensions. So once we kind of generated that and saved it, for example, in a file, then we can follow this workflow to convert to a specific format that CHAP requires. There you have it at the bottom. This is publicly available. So we have a DHIS2 library. In that library, we have what we call this data frame to CHAP CSV API. What this does is it takes all your data, all these four, for example, and make sure the required columns that CHAP expects are available. And of course, you can also do a mapping. You don't have to necessarily, at the source level, you don't have to necessarily have the same column names, and the library helps you do that. And then you just pass to that, and then finally you get an output CSV file that can be consumed directly by the CHAP platform to kind of help you kind of visualize this, and that's how it kind of flows. We have the different data sources. Like I said, this can be either a global data source or a local data source. The dengue cases population, for example, we have seen a world pop. The climate data, it could be ERA5 or CHIRPS or Enactus, or for that matter, if you have a good contact with the local Met office, you can also make use of that. And then you have to have the admin boundaries, or like Karim showed us, the ORGNIT boundaries, the ORGNIT GeoJSON file that you can download, for example, from DHIS2. So this, the processing pipeline, it pulls all this and then make sure that on the same space-time index. So what you have is one row. In that row, you have all these columns, each of them sharing the same temporal and spatial dimensions. And at the same time, like I said, the CHAP API makes sure these reserved keywords or columns are present. Otherwise, CHAP will reject your data, location, time period, disease cases. Population is also nice to have, but it's not really required at the moment. And then we also have your data can also have other covariates. So one thing very important here is this harmonizer library. It doesn't do any data imputation. Like if you have a blank missing data, then it will remain as missing data in the harmonization process. So that's a little bit of integration, like integrating data from different sources, combining them into one harmonized, and then feeding it into CHAP. And then speaking of integration, we have like a kind of a prominent system in all our conversation, like let's slide this from the earlier. We have the DHIS2. So we either pull data from DHIS2 or push data into DHIS2. To kind of simplify this process, we have created DHIS2 Python client as part of this the Climate Tools library. It's a library developed to connect DHIS2 with a wider data science ecosystem. Of course, DHIS2 or the other data source has its own API and can be integrated literally with anything. But for this specific project assignment, we have developed a Python client because that's how the CHAP ecosystem, and of course, Python is also the language of data science. So to make it convenient, we have created this library using Python. It helps you to safely get data out and into DHIS2, and the other way around also. Like you can deal with data frames, XRA, all those things you can deal directly with the Python. So as you can see here, using this API, you can, Python client, you can talk with DHIS2 API, access metadata, manipulate metadata, and the same thing, access data and manipulate data as well. How you generate that data, I mean, like we just showed the earlier workflows, there are tons of ways of generating your data. You can pull metadata using the API, like for example, the data element ID that Karim showed us earlier. And then once we produce the data, we can generate a JSON payload using that API, using that data element ID. And then that can later feed back to DHIS2. So in general, this Python client kind of simplifies your life or your interaction with the DHIS2 system. Some of the key functionalities we have. It uses a dict object. Well, for now, it's just a sync, but we are planning to extend it to make it async. You don't have to deal with paging manually or you as a programmer, because this is part of, if you know DHIS2, you have to have this paging parameter, and then by default, it gives you only 5 items at a time. So if you are going to pull a lot of data with this, for example, all your districts, so that you can combine it with temperature or disease data, then you have to go either page by page, or using this API, this Python client, you can just go fetch them in one go. And that helps a lot. In general, all the API endpoints that DHIS2 supports are available via the Python client. That's the raw API access. But for some of the most widely used endpoints, we also have what we call these convenient methods, like to interact with users, to interact with organization units or your districts, provinces, to interact with data elements. That could be temperature, the data element that you are going to store climate variables like the temperature, precipitation, or even could be the population or the disease. All this you are going to interact via the data element. So we also have convenient. And then finally, once you have gone through the workflow that you have to go through and then generated the payload to interact that, we also have a convenience method for dealing with DHIS2 data values. So in general, it simplifies access. It enables bidirectional data exchange. It also streamlines metadata creation. I mean, you don't have to go manually via the UI, the maintenance, and then the UI side of DHIS2. So you can fully automate the entire metadata creation workflow. And some examples to kind of inspire you how you can use this. You can create data element using the Python client. You can also, like the data element could be the temperature variables. Or in fact, if you go to the GitHub and then see the Python client itself, DHIS2 Python client, there we have the examples where you can go through them. Like if you want to create fetch org units, that's how it is. If you want to fetch a GeoJSON, you also have access to that. If you want to create a data element, fetch data element or create data element, for example, the air temperature, ERA5 land, max air temperature, mean air temperature. I mean, it's up to you which climate variable you wanted to create. So then finally you have the client post. That client is basically the Python client. It's kind of a wrapper function to that. And then you can just make a post to that. And that way you can create your data element. But again, like if you want to go full the entire workflow, starting from metadata creation all the way to data preparation and then pushing data into DHIS2. We also have an example, which is again publicly available on the Python client. Yeah, I think since this is kind of pretty much available, I'll stop here. I think to give time for Morten, but if there are any questions, please feel free. Thank you.
Thank you, Abjot. Let me just share my screen. Right. Okay, so I'm just gonna quite quickly show you how you can go from what Karim was showing you off the notebook into something that you can actually put on a server and something that will be schedulally imported basically to your DHIS2 instance. So obviously the slides will be shared after, so feel free to just click on some of these links. But the one that Karim was showing, I'm just going to show you how we kind of automated that and made it into something that you can run on your actual server. So first of all, okay, let me just show you that also. There is a link to a repo here that just shows you everything. It has, if you look at the main pie, which is actually not used anymore, but it kind of shows you kind of the direct conversion from the notebook to the actual production stuff. So the biggest changes here from what Karim was showing you is that we are getting all these variables from the environment, and this will later help us in a way that we can actually package this as a Docker container, basically. So you can have one container that you can run multiple times with different URLs, different variables, and so on. And you will see the defaults here, like the total precipitation is the default for the variable. But that might not be what you want, but that's the default. So then you can override it. Okay? So yeah, so if you look at the repo again, there is an .environment example here that kind of shows you all the different things that you can change. I'm not going to go into the details here, but it's pretty self-explanatory, I hope so. And I think Karim also went through some of that stuff. And again, if you look at the main pie, it's basically the same as the notebook, just adding these environmental variables. So, okay, so let's actually show how this works. So I have this repository here locally. This is one we looked at. So if you do make help, that will just help you a little bit of a guide what's next. The absolutely simplest one is to just make run, just basically run the main pie using the defaults from the local environment, right? So we will do that. So let's just copy an example here, and then we can show what's inside it. I will not show the entire file just because I have my CDS key there. So, and that's private, but you will see we are targeting the play server. This is the username password. We will do a very kind of smaller import for about 2 weeks. And then this is the data element ID. And don't worry about the cron. Dry run by default is true. And that just means it doesn't actually import anything. It will just kind of make sure that everything is okay, but it doesn't import any kind of data. So again, quickly I will show you, this is the server. You can log in with admin district. I created a data element for this one. This is the Copernicus, the climate data store. Obviously, the name you probably want to change. This is for precipitation, so you probably want to change that. But as an example, you just call everything CDS. It's a number. We are targeting the aggregate part of DHIS2 and not the tracker part of DHIS2. So the domain should be aggregate. And other than that, nothing more to say. If you need the UID, you will go into show details. You'll see this one is the same as this one, right? So this is our target, right? So that's just the input element, basically. And in DHIS2, you cannot just import it based on data element. You need to be linked to some kind of data set. So we also created a CDS dataset. The important stuff here is that we have to be a daily target because that's what you want. And then, of course, in the data element section, we have selected the CDS, right? And then we have, in this case, I mean, that will depend on the use case, but we have connected to all the districts. So that's level 2 in this instance, right? And if you go here, this is the DHIS2 data entry app. Let me zoom in a little bit. You can select CDS. Let's select, in this case, this bow. And the period, let's just select, so 2025. And this start all the way down here, that should be 1st of March, right? So there's no values, right? Because we haven't, this is our target, but we have done nothing yet, right? So there's no data in DHIS2, nothing. Okay, and then so I go back here again to my editor, and then we go to the make file, and then we do run. What it actually does is actually run the system. Again, please have a look at it, and please come back to me if there's any questions around that, but it's basically just running it on your computer, nothing Docker, you're just running it on your computer, and it will give you some feedback. So let's do that. You just make run. Again, you can also do climate run. It's the same. It's the same. So now it will go to the server. It will fetch all the DHIS2 required elements. See, this is the data element we mentioned before, and so on. And now we have sent a request to Copernicus, the CDS server. Can we please have this data? Sometimes it take a little bit of time. It should be hopefully very, very quickly done. And then when it's done, you will be able to see that there's data here. What is running? Let me just show you what I did before. So let's go to, because I did import February before I started this presentation. So you see this data here, right? So, and again, this is for this particular time. So this is the 1st of February, and you can move down again. You can do like the, let's see, here it is, the 2nd of February, so on. So you will have a data for about 2 weeks in February. It is a bit slow down, so I will just leave it on the background. There is also Docker targets. So one thing we do have, and I just want to show you again what we have configured here. You'll see that our cron is star, and that basically means run every minute. Again, just for a demo. And if you go to this site, crontab.guru, again, it's linked in the slides. I would highly recommend this one for figuring out how you should run things. So yeah, again, just what you call a cron expression. And this is where you say, I want to do it. For example, right now we're doing this, right? So it says at every minute. And you can do like at every 15 minutes. So 1:15, 1:30, 1:45, and 2, right? So it just goes around. Okay. Let's see if you're lucky. CDS can be slow sometimes, and see some records in our new part data. It will finish, but let's not worry too much about that. So at the end of the day, you will be left with data. And again, if you look at the schedule, if you know Docker, and please again, I put my email address on this slide just because I understand some of these are complex. But basically, what you can do is that you can run this this command in the background. So if you have a server, you just start it up, D for background service, and it will run every so often. Don't do it every minute. That was just an example. I think every week or something is probably something you want, because the way it works right now, if it's February 1st, it will not import data because there's no data available yet, right? So only on March 1st, you will get the data for the February period. So yeah. Oh, and we did get imported. That's good. So you'll see here now, this is from DHIS2 saying we imported 377 new data items. So let's now go to, let's just clear everything out. Just select again what you wanted. And the period, in this case, then would be March. So let's do March 1st, just to confirm this data. Oh, sorry. This is this is not for March. Sorry. Anyways, that's basically how it works. Yeah, you will see this data here. This is the last part of February. Yeah, so I think that's enough. I think we should have some time for questions. Please come back to me if there's any questions around this. Please have a look at the repository. There are also some docs linked to that, which will explain a little bit more detail how we go from like a simple script that they have in the machine or notebook we have in the machine, and then through something that is sketchable and so on. So I think now I will move back to I think Karim and Björn to finalize the last part. Thank you.
I think the light turned off here, but it's okay. Okay, so I'll share my screen. Yeah, we're gonna very briefly very soon move over to the questions. Just a very quick note at the end. How to contribute. So we've on this website, we've put a few guides of different ways to do things and different workflows. But yeah, we want this to have contributions from everyone. So if you have a particular use case, you download, install Climate Tools. You can start separate, in your own GitHub repositories. You can start making your own notebooks. And if you think they would be useful to share, then you can contribute it back. So that we show it on the website, and it'll be part of the toolkit for others to use. So we recommend so if you want to contribute back, you start by going to the community of practice. This is there's a link here, but you can also, if you go on the website, let's see. Yeah, there's on the contributor, it also has a link to the community of practice, and also here in the top, you can go to community of practice. So this is this kind of a forum where I guess it I think my browser restarted, but okay, so community here. So it's this forum where you can make posts and ask questions and so on. So we recommend that you start by going there and asking about what you're wanting to do, and if you need any advice and so on. I think because my browser restarted, I lost the presentation, but basically we just want you to go to so you start by asking a question, and then you can go to the GitHub repository, make a fork, so you have your own version of the repository, and then you can make your edits and create a pull request back to the repository. So I think, yeah, and we have one example of a contribution that was made. So that's an aggregation here. So Sri Lanka had a use case where they wanted to look at population exposure to air quality. So we worked with them to integrate and make a notebook that looks at this specific use case that they had. So it's using air quality data, local air quality data, and integrating that with their health districts and population. So I think that's it. I guess, Björn, any last words, or we're just open for questions? I guess we're a little bit over.
Thank everyone for presenting. We're a little bit over time, but I've seen there have been many questions in the chat, and I feel we have answered all of them. If you have more questions, please reach out to us to the community of practice. That is where we would like to have questions, because often the questions are also relevant for others. And then also to note that this webinar was recorded and will be available on the YouTube channel. And we will also share the slides after the webinar. So unless there are more questions in the chat, it doesn't look like so. So thanks for joining, everyone. Good luck with the climate tools, and please remember this will only work if we all collaborate and share code back to a common good. So please, if you figure out something smart, please share your code with us, and we will include it in the climate tools. Okay, thanks for now. Bye bye.
Thanks, everyone.
Thank you.
Very good. I was wondering whether I should come and help you with a light, Karim, but I think it worked with a screen.